When we talk about the factors of a number, what we're really talking about are all the different ways that we can take something that's just a pile of objects and organize it into a nice orderly way. So, for example, let's talk about what the factors of the number 16 are. If we imagine just 16 objects, so let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 objects, this is perfectly valid as 16. But we could organize it better if we wanted. After all, we could look at 16 and we could transform 16 into one group 16. We could line all this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So what that means is that we could look at factors, in other words, things that make up 16, as being 1 and the number 16. In other words, 1 times 16, or one group of 16, is a way to get back to the original meaning. So when we're talking about multiplication, we're really thinking about groups. How can I group all of these? Can we make groups of 2, for example? So let's now look and say if I can make groups of 2. So I would have 1, 2, 4, 6, 8, 10, 12, 14, and 16. And sure enough, we can look at having a factor of 2 or a factor of 8. What about groups of 3? Could we do it with 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 3 is not a factor of 16. It's not something that I can use as an effective way of organizing all of this as a rectangle. So 3, not a factor of 16. 4, however, would be. 4, we could look at and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15, 16. So 4 is another factor of 16. Is 6 a factor of 16? No, it wouldn't be. Now, how do I know this for certain? Well, notice that as we've explored through these factors, we eventually got to a place where I had 4 groups of 4. And we had already explored all of the other factors of 16, namely 1 works, 2 works, and 4 works. 3 doesn't work, and there are no other numbers that we could have explored as we begin to now grow our rectangle in the other direction. We have to go, so for example, let's try 5. If we had it, would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So 5 does not work. 6 would not work. We would end up getting 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, too many. In fact, I think I drew too many even when I was counting. So we would need to take this all away, and that would be what? 12, and 3 more is 15. So 16 would be, doesn't quite work. 7 wouldn't work. 8, is 8 going to work? It will. And we know that because it appeared right up here. In other words, making an 8 long rectangle is going to get us the exact same thing we had before. Let me see, 1, 2, 3, 4, 5, 6, 7, 8. It's going to get us the same thing we had as the previous rectangle. We've just tilted our head sideways. Do we see that? That here, this rectangle is an 8 by 2, and this one here is a 2 by 8. So once we've found the factors and we've kind of worked to this halfway middle point of saying that we have swapped essentially all of the widths with all of the lengths, we're done finding the factors of 16. So what are all the factors of 16? If we were to look into it, we would say 16 has the factors of 1, 2, 4, 8, and I think that's it, right? Because otherwise it's just going to eventually go back to, and 16. Now, for the reasons that we've shown here, oftentimes it's helpful to look at this in terms of its prime factorization. The prime factorization is useful because we could very easily look at 16 as being 2 groups of 2 groups of 4. Right? We could look at this as saying, here we are, where there's actually 2 groups of 2 groups of 4 here instead of 8. Can we break it down more than that? Sure, we can look at 2 groups of, well, how much more does it go down? For these kind of ideas, what we'll want to explore is often what's called a factor tree. So we look at 16 and we think about all the different ways that we can split it. We could, of course, split 16 into 16 and 1, but we haven't gained a lot of insight into what makes up 16 by doing this. Instead, let's start with the next number. So this would be 2. And we could say that 16 is really 2 times 8. Wonderful. Well, what about 2? Is there anything that we can multiply up to 2? Well, we could multiply 2 and 1, but that doesn't really get us any more insight than just saying I have 2 objects, so we'll ignore that for now. What about 8? 4 times 2 works out just fine, and 4 is 2 times 2. So when we're looking at all of the things that make up 16, we can look at this and say that 16 is really just 2 times 2 times 2 times 2. Here they are, 1, 2, 3, and 4 different 2's being multiplied together. And in fact, as you go through all these numbers up here, this 2, this 4, this 8, and this 16, it's nothing more than the prime factors, these kind of fruits hanging off of the factor tree, that are being organized and recombined in different ways. When we discuss the greatest common factor, what we're really looking for is a way to organize all of a whole bunch of different types of piles under the same organizational structure. In other words, we're looking for a way to kind of build up those exact same types of rectangles. So here, if I'm looking for a greatest common factor of 4 objects, 12 objects, and 16 objects, what I want to think about is what is the rectangle I can create, what does the width have to be, such that if I make it some kind of width, I will be able to nicely fit all 4 objects, 12 objects, and 16 objects inside of this rectangle. So for example, could we make it the number 2? Well, absolutely. If I make it 2, then how many groups of 4 do I have in here? Or how many groups do I have in the 4? I would have a group of 2 and a group of 2. So here we are, 1, 2, and 1, 2 account for all of my 4. For my 12, I would eventually have 6 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my 12 fitting in nicely. And for my 16, it would work out as well. I'd have 1, 2, 3, 4, 5, 6, 7, squeeze in 8, and again 8 more on the bottom. So 2 is a common factor of 4, 12, and 16. But is it the greatest common factor? Well, that's an interesting question. Let's see if we can go bigger. Does 3 work as the greatest common factor? No, it does not, because it's not a factor of 4. It's also not a factor of 16. And we can see that because if I tried to organize 4 into groups of 3, I would have 1, 2, 3, and then, oh, not enough to get another group of 3. So 3 does not work. Could I try 4? Let's try 4. But instead of drawing dots, maybe we'll just try to represent all of this using our symbols. After all, if we're looking for 4 things going down, 1, 2, 3, 4, I guess that takes care of our first 4. What about for the 12? Wouldn't that be 4 groups of 3? So if this is one group of 4, we would be able to say there's 3 groups of 4 to make up the 12. And then we could say there are 4 groups of 4 to make up the 16. This, as it turns out, is actually a much faster way for us to look at what the greatest common factor is between a number of different things, is that we're looking at the rectangles we can build if we're trying to organize everything together. So we have 4, 12, and 16 have a greatest common factor of 4, because 4 is the biggest thing that can multiply into 4, 12, and 16. A quick way to find the greatest common factor between 4 numbers, or any numbers, let's say 4, 12, and 16, is to first break them all down using a factor tree. So we can look at 4 and say, what are all the numbers that are the prime factors of 4? Well, 1 is not a prime factor because 1 doesn't give us any additional information, but 2 groups of 2 is definitely a nice way to organize this. 12, what can we do for 12? 12 could be, well, 2 multiplies up into 12, so 2 is definitely going to be a factor. And it'd be 2 times 6, and the 6 can be thought of as 2 groups of 3. And for the 16, we can break that one down into saying we have 2 groups of 8, 2 groups of 4, and 2 groups of 2. So all in all, what we are talking about is that 4 is equal to 2 times 2, or 2 groups of 2. 12 is equal to 2 groups of 2 groups of 3, and 16 is equal to 2 groups of 2 groups of 2 groups of 3. Well, what's common between all these? They certainly all have a 2. They certainly all have another 2. They don't all have a 3, and they don't all have a third 2. So if we're looking for where the similarities are here, we can say that what's common between all of these is a 2 and another 2 being multiplied together. In other words, their greatest common factor, the greatest common creator component in here is 4.